So in the rest of this chapter, we're going to focus on two ways to make sure that we are measuring our data well. One is reliability, and the second is validity. So this video is going to focus on reliability. There are three different kinds of reliability that we're going to be focusing on here. One is test-retest reliability. The second is interrater reliability. And the third is internal reliability. We're going to go through these pretty quickly. With test-retest reliability, we're looking at what happens the first time, what happens the second time. And so, for example, with these measures of 4 babies, we're seeing that their head circumference is not exactly the same the second time. On the other hand, across the 4 different babies, we're seeing very consistent scores, and we can, very close to a correlation of 1. Now let's go to our divergent association task, which we talked about in earlier videos. Here we have a test-retest. Remember, you took the divergent association task twice. You see that we have a correlation of 0.4. It's certainly not where we would expect. And there's a whole lot of scatter here. The scatter means that we're not really able to well predict what happens on the second administration of the task, knowing the first. 0.4 is generally a good number, but not when we're thinking about test-retest reliability. Now, there are a number of reasons why it might not be higher. It may be that people took the test back to back and weren't really paying attention to it the second time because I've already done this. Maybe they didn't care. Maybe wasn't a whole lot of motivation attached to that. And so, depressed the scores. Here's our second measure of reliability, interrater reliability. Again, we see that, here we have a nice pattern where almost all the children are rated similarly by both Matt and Mark. However, with this measure, we have a much poorer relationship between Mark's ratings and Peter's ratings. So in this case, we just don't have very good interrater reliability. And we would probably suggest either that there's a problem with the measure or that, Peter and maybe all of the researchers need to go back and train some more on the measure. Now we can use correlation coefficients to evaluate the reliability. So we're going to pay attention to the slope. So what kind of relationship is there between our X and Y variables? The strength of the correlation coefficient, which is down here below the figures. And so part of what you should be asking is, which is the strongest correlation? Which is the weakest? Think about what the dots mean here. And which are positive and which are negative correlations. Now, these are general kinds of issues to be thinking about. When we go back and we're thinking about doing reliabilities, if we get a negative reliability like this, negative correlation, that probably, well, that certainly is not a good finding, because what that says is that as one person rated a person high, the other person rated them low, and vice versa. So not good reliability. In terms of our third reliability, this is internal reliability. Often you'll see in measures similar questions across time, where we're able to compare and see whether there's some consistency in measurements. These are often described in terms of average inter-item correlation, or sometimes that's called Cronbach's alpha or coefficient alpha. So, we want as strong a correlation as possible among them. Okay, let's take another side trip. This time we're going to be looking at correlation matrices. And what you see is the pattern among 5 variables. So you see these variable names both at the head of the columns and also here under the rows. You'll notice that along the diagonal of every correlation coefficient, there is a perfect correlation, which makes sense because we're talking about correlating a variable with itself. Because, let me go back, because you'll also see that these correlations above the diagonal are actually the same as those below the diagonal. So our studying with exam score is 0.82. Similarly, our studying with exam score is 0.82. And you can go through, and unless I made a mistake, they should be exactly, the same. As a result, what we often do is remove the scores above the diagonal, just to make this a little bit easier to understand. So let's stop and think about what Cronbach's alpha means. Generally, we want a Cronbach's alpha of 0.9 or above. So the lower it is, the less consistent our variable is and the measures are. And we may even want to consider throwing out some measures or adding some measures, or rewriting them in order to get a more consistent measure. So this is looking at the satisfaction with life scale and thinking about internal consistency, and so like AIC, and test-retest reliability. And you see that we have a number of different studies that all reported on this. And while the AIC or coefficient alpha differed across studies, they were all generally pretty good. Test-retest was pretty good for short periods, moderate for longer periods, and the longer it was, the more test-retest reliability dropped. Not surprising. Between now and 4 years, some of you will have lives that will be much better, and some of you will have lives that may have more problems. So let's go back to our 3 kinds of operationalization. Think about how you would measure reliability for each of your 3 measures of political orientation. Whatever self-report measure you developed, whatever observational measure you developed, and whatever physiological measure. and take care. I'll see you in the third video.